Today we are going to do the theorem. That is, if P be a prime number and P divides A square, then P divides A. That means A square, the P divides A. A means square root of A square, where A is a positive integer. Understood? Proof. Let the prime factorization A be as follows, as A is equal to P1, P2, Pn are primes. Not necessarily they are distinct. What do you mean by distinct? Distinct is not they are different. They are not different. So therefore A square we write. The square means twice multiply this multiplied by this. P1, P2, P3 Pn into P1, P2, P3 Pn. When we multiply, we get P1 square, P2 square Pn square. Now we are given P divides A square. P divides A square. We realize that by fundamental theorem of arithmetic, we realize that only prime factors of A square are P1, P2, P3 Pn. Okay. Since P is one of the prime factors of A square are P1, P2, P3 Pn, so P is one of P1, P2, P3 Pn. It can be anyone. P can be P1, P can be P2 Pn. Now so I can write A is equal to P1 into P3 into Pn. So is equal to which divides, that is which divides A. I do another theorem, that is root 2 is an irrational number. Irrational number means neither it is a natural number, nor it is an whole number, nor it is an integer, nor it is a fraction. So, but now by contradiction, I will be doing that. Let us assume that root 2 is an rational number. It is a rational number. So therefore, root 2 I can write P by Q, comma Q not equal to 0, where P and Q are co-prime numbers. What do you mean by co-prime? Co-prime means that is they don't have a common factor. They don't, suppose give an example of co-prime, that is 3 and 5, 4 and 9, etc. etc. Now here that is 2 is equal to P by Q whole square, squaring both the sides. Okay, that is 2 is equal to P square by Q square is equal to 2Q square is equal to P square. Okay? Now then we find that is P is an even. P is an even because it is multiple of 2. So P is an even. I can write P is equal to 2m, where m is an integer. So P square is equal to 4m square. From 1, 4m square is equal to Q square implies 2m square is equal to Q square. I write 2m square is equal to Q square, which says that Q is also an even number. So that means P is also an even number, Q is also an even number. So they have a common factor 2, which contradicts our assumption. So we can prove by contradiction that root 2 is an irrational number. We will be doing exercises. Prove that root 3 is an irrational number. Solution. Let us assume, like the previous one, root 3 is a rational number, and therefore root 2 is equal to P by Q. Q not equal to 0, where P and Q are co-prime. Earlier in the theorem I told co-prime. So it is a co-prime numbers. Therefore, I square both the sides, then I get 3 is equal to p square by q square is equal to 3 implies 3 q square is equal to p square implies p is a multiple of 3. Sure, that is if multiple of 3. So therefore I can write p is equal to 3m. M is an integer and p square is equal to 3m whole square, that is equal to 9m square. Q is also a multiple implies, that is q is also a multiple of 3. That means it contradicts our assumption, that is q and p are do not have this common factor. So by contradiction, it contradicts our assumption. Therefore, root 3 is an irrational number. Another exercise I give you, that is prove that 5 minus root 3 is an irrational number. So now let us assume that 5 minus root 3 is a rational number. That means 5 minus root 3 is equal to p by q form, where q not equal to 0, where and p and q are co-prime numbers. What do you mean by co-prime? They don't have a common factor. So I can write this way. I take p by q this side and root 3 a different side. Now 5 is a rational number and p by q we have assumed that it is a rational number. So one rational number minus the other rational number, we get a rational number only. Okay. So this is a rational number. 5 minus p by q is a rational number. So from this relation we get root 3 is also a rational number. But in the previous question we have already done root 3 is not a rational number. So which contradicts our assumption. Contradicts because root 3 is not a rational number, we have done earlier also. 5 minus root 3 implies 5 minus root 3 is an irrational number. It contradicts means 5 minus root 3 is an irrational number.